Math 95 is, yeah, kinda. I mean, yeah, it's kind of like that, I think, more than anything else. It's kind of hard. I mean, it's not real hard to play it. Yeah, I'm just having fun here, trying to get this all to work. I'll probably just give up on it. All right. So you can get the main screen ideas right in here anyway. So this is a little geometry application here. I'm just going to draw a line, show you kind of how this works. And let's see, put a point on there. There we go. And I want a perpendicular to this line. So that point should work. And then this point here. There. All right. Okay, so basically here, this is a triangle. And I can change the triangle here, okay, to make different types of triangles. Now, this is a right triangle, okay? Trigonometry only works in right triangles, basically the kind of trigonometry we're going to look at today, all right? And if I move this around and form different triangles, these triangles are all the same shape, but they're different size, so we call those similar, all right? But trigonometry has to do with different types of ratios. So I'm going to measure all these sides. Okay. And then I'm going to make a ratio. I'm going to make a couple ratios. Put that one there. And one more. Put it up there. Okay, make sure I did it all right. Okay, so the first ratio we're going to take a look at is this one called opposite over adjacent. So if we have an angle down here, all right, and the side that's directly across from that angle is called the opposite side. And the side that is right next to the angle is called the adjacent side. The one that we want to make sure we always distinguish when you're doing anything with right triangles is this side, because this one's called the hypotenuse side. Okay, and maybe some of you might remember from a while ago that a squared plus b squared equals c squared. It's a pretty famous mathematical idea called the Pythagorean theorem. All right, a and b don't matter in that case, but c always did. Okay, and it's kind of an important idea if you did some things with construction and stuff like that. It has a ton of applications, but in our case, we're just going to be interested in this opposite or adjacent idea. So let me show you what happens when you do some measure. Let's see, I want to do this guy, and I need to select the adjacent, so I'm going to select this point here, select the opposite, that right there, and put it right there. Okay, so what I did was I went ahead and found the ratio. Oh, that was good. I found the ratio of opposite over adjacent, and it's 1.2. And now what I'm going to do is show you that as I move this triangle around to form different size triangles, that ratio always stays the same. It doesn't change. Even though the numbers in the sides change, that ratio stays the same. Okay? And that ratio is called tangent. So tangent is equal to the opposite side of the angle. Here's the angle. Opposite side is this. Adjacent side is this one. That ratio is always the same. Okay? Same thing's going to happen here on these other ones. We'll go ahead and I'll show you those too. We'll calculate this one here. See, it says select hypotenuse, that's that guy. Opposite side, that's that guy. Put that number right there. Okay, and then again, I'm going to go ahead, move this around. Okay, and you can see that this ratio, this 0.769, always stays the same. Okay, that one's called the sine ratio. Opposite over hypotenuse. And then the last one of all the ratios that we have is this one. So let's see, adjacent is here, hypotenuse is here. I'll put that guy right there, press escape, and once again you see that that ratio stays the same. If I change the angles, then the ratios do change. All right, but as long as I keep the angles the same, okay, and get just a bunch of similar triangles, those ratios stay the same. All right, so that's the basis of what the supplement is about. So what we want to have, so what we have here is that tangent, that's the ratio, and it's abbreviated in your calculator as tan of an angle, okay, is equal to the opposite side over the adjacent side. All right, so that's the tangent of an angle. Okay, the sine, which looks like this, but is abbreviated with, is equal to the opposite side over the hypotenuse. And the cosine of an angle, which is spelled that, but abbreviated this, is the adjacent over the hypotenuse. Okay, so those are the three trigonometric ratios that you're going to just need to be concerned about: tangent, sine, and cosine. Hopefully you have a calculator with a sine, cos, and a tan button on it, because if you don't, then it's going to be difficult for you to do some of the problems on the supplement, but we'll do them together anyway. But it'd be good if you knew how to push that button and get the answer so when you follow along. All right. Let me give you an example, a little bit of how it's used. All right. Not a real life application, but just a triangle situation. Here's a triangle here. If we have an angle 60 degrees, okay, we know that this adjacent side is 10, and we're trying to figure out this height side here. All right. The toughest thing to do in trigonometry, I think, is to figure out which one to use. Once you know which one to use, then it becomes easy. So what you want to do is find the angle first. So we're going to find the angle, which is here. How about that? There we go. Okay, that's the angle. This side is the side opposite because it's directly across from the angle. And this one here is the side adjacent. Opposite, adjacent. Okay, so in this case, we're going to use our sine, or excuse me, tangent, because tangent is the ratio opposite over adjacent. So if we go tangent of 60 is equal to opposite side, which is x, over the adjacent side is 10. It's going to be just like a proportion, like what we were doing in 2.8. So I take a handy-dandy calculator and I figure out what the tangent of 60 is. All right. The only possible problem we could have is our calculator is in the wrong setting, because for angles there's three types. There's gradients, radians, and degrees. So you want to just make sure yours is in degrees. All right. Did anybody find the tangent of 60? You just go tan 60 probably. This might be meaning we didn't find the tangent of 60. Good. Square root of 3 is the correct answer. Scientific. See, I have a little tangent button here, so I'm going to go 60 tangent, see what it tells me. Now I get 1.73205. I'll just take the 1.73. Okay. But you can use the square root of 3. It isn't making any difference. but as a decimal, it's 1.73. We would just simply put that over 1 because 1.73 is just a number. We can put any number we want over 1. We can cross multiply, and x is equal to 17.3. Okay. So that's an example of how you would use tangent. Sine and cosine are very similar to that. Again, the hardest part, I think, is to be able to figure out, hey, which one do I use? Because I can push a button. You know, we can get, a lot of people can push buttons, but how do I know which button to push, and what does it really mean? So if I have another triangle here, another right angle here, I'll put a 40-degree angle here. This time I'm going to put 20 here, and we want to figure out this slanted edge, all right, which is our hypotenuse. So again, we know the side that is opposite, but we don't know the hypotenuse. The hypotenuse, remember, is opposite to 90. Okay, so in this case, I have opposite and hypotenuse, so that's sine of 40 equals the opposite side over the hypotenuse. Okay, so I use that button again. I go find the sine of 20, so I'm going to go 20 sine 0.342. Okay, so I'm going to go 0.342 equals 20 over x. Put that over 1 and cross multiply. Yeah. Did I put the wrong one?
Yeah, you did sine of 20.
Okay.
1.642.
0.642. I don't know why I said 20. Oh, because of that guy there. Okay. 0.642. All right. Now we can cross multiply. Thanks. 20 is equal to 0.642x. And then we divide. Let's see, 20 divided by 0.642. What does that turn out to be? 31 point.
31.15.
Okay. All right. So, you know, basically that's kind of how you do some of the stuff in trigonometry. I don't know how much of it you're going to really need to know in your future. So, you know, if you were doing some things in construction or engineering, you know, or something like that, you're going to run into it. All right. So, in some of your classes as you move along. But in many cases, you probably won't. So, in the back of your book, I'm hoping anyway, back of my book, which is the same as yours, I think, it's right behind the pages that have the little black border. There it says supplement back there. And we want to look at the supplement 2.8. All right. Now, they also have these cosecant, secant, cotangent ones. I'm not really sure why, because you know, in right triangle trigonometry, you hardly ever use those, but they introduce them down here, and they're just the flip of the ratio. Okay, but really, normally you wouldn't really use those very much. Okay, so here's a little example they give you. They come down on page S5. It says some people like to use the mnemonic device SOHCAHTOA to remember the relationships. SOA means sine opposite over hypotenuse. Ka means opposite or adjacent over hypotenuse. TOA means opposite over adjacent. So it's just something that has been used for a long time. SOHCAHTOA. Okay. Years and years and years ago, they used to refer to it as Indian chief, but they quit doing that for obvious reasons. But there's just a little history on that. So let's just work through exercise 1. Okay, and I don't really care since we're just doing these. Let's not do the cosecant, secant, cotangent. I just really don't see a need for that. So on a piece of paper, because remember, you're going to turn this in, and we're going to get free points here. You can just title it like Supplement 2.8 on the top. Wish I could get this thing to move over. No. Okay, I'm going to try to draw this little chart here. Like that. There's this. And then there's a sine, theta, cosine, theta, tangent, theta, 30, 60, 90. And you may say, well, why did they just pick those ones? Well, 30, 60, 90 is kind of an important trigonometric triangle, I guess, so to speak. Okay. And so that's why they picked those particular degrees. So they give us this triangle here. Oh, no, it's not 90, it's 45, isn't it? Sorry, I didn't see that. I just assumed it was going to be 90. Okay, 45. So 30, 60, 45. All right, and they give us a triangle on the top like this, and this is 30, and this is 60, and this is 2 square roots of 3, and this is a square root of 3, and this is 3. So they're using these because usually trigonometric ideas are expressed in exact values rather than a decimal value. Now, if you were doing something practical, it would be in a decimal value because, you know, if you were making something that required you to do this and you went to cut a board or make something of design and you said, oh, I want to make it square root of 3 feet long, you couldn't find that on a tape measure, so it wouldn't make any sense. But in this case, they want us to do it this way, so we'll just do it this way. All right, sine of 30. So here's 30. Remember, sine is opposite over adjacent. Opposite over hypotenuse. Sorry, thinking of tangent. My bad. So here's 30. The opposite side is the square root of 3. And the hypotenuse side is 2 square roots of 3, because here's my 90-degree angle right there. So what's going to happen to these square roots of 3? They're going to cancel out. So this ratio is just going to be, there's 1 square root of 3 up here, so it's going to be 1 over 2, because the square root of 3's all go away. So that's that one, 1/2. All right, so we're just going to keep going across the top here. Cosine of 30, that's the adjacent side, that's 3 over 2 square roots of 3. Okay. Now, normally you can't have a square root here on the bottom, but that's like math 95 or 65. They might talk about that, but this is math 60, so we're going to allow it today. So we're going to go 3 over 2 square roots of 3. Okay. And remember, I don't make these, right? This isn't my, I'm saying we did, okay? So, because I probably wouldn't have done this, but anyway, they want us to do it, we'll do it. Tangent of theta, that's going to be, or 30, is going to be opposite, which is the square root of 3, over the adjacent side, which is just 3. So in the chart, I'm going to put 3 square root of 3 over 3. And that one is okay. You can have a square root in the top of a fraction. You know, they just don't like it to be in the bottom of a fraction. All right, so we got the top row figured out. Now we're going to do the 60 angle here. Okay, so we'll start off with sine again. I'm going to change it to a little different color. So sine is going to be here. 60 is my angle. Opposite is going to be 3. Hypotenuse is still the same thing. All right, so that's going to be 3 over 2 square roots of 3. And hopefully you see that it's the same thing as that one. So what do you think the cosine of 60 is going to be? Since these two are the same, what do you think the cosine of 60 is going to be? Well, let's try it out. So here's 60. So we want cosine, so that's the adjacent side, so that's the square root of 3, over the hypotenuse, 2 square roots of 3. What happens to the square roots of 3? They cancel out, and we get a half. So see, now these two are the same. So they flip-flop. Okay, so the tangent, okay, here's 60. Tangent's going to be the opposite side, which is 3, over the adjacent side, which is the square root of 3. There's another thing that is not quite right, but we're going to do it anyway. We get that. And you might notice that these flipped. Okay, so just like these kind of became, they're the same thing, but they kind of flipped, or not flipped, but kind of interchanged. This is just a reciprocal here. Okay. So that's the end of the 60 degree one. Now we got to do the 45 degree one. So let's take a look at that one. That one looks like this. Here's my right angle. Here's 45. Here's 45. And let's see, they put 2 here, and 2 square roots of 2 there. So now we'll go ahead and do that ratio and finish this problem off. So we have sine of 45. I'm going to pick this angle down here. Opposite over hypotenuse. So it'd be 2 over 2 square roots of 2. What's going to happen to my 2's? Cancel out. Since I have a 2 still, it's still going to be 1 over the square root of 2 like that. Okay. Again, that would be another one that we're really not supposed to have that, but we'll just let it go since we're just messing around with this anyway. So we have 1 over square root of 2 there. Cosine. I'll pick this angle down here again. The adjacent side is also 2 over 2 square roots of 2. So this time they're going to be the same thing. And because it is a 45, 45, 90 triangle, that will be the case. All right. And remember, you can change. We could have taken these triangles. As long as we keep the angles the same, these ratios are always going to be the same thing. So in other words, if this side was 10, we could figure out these other two sides because they have to have the same ratio. All right, let's do tangent. So tangent is equal to opposite side over adjacent side, 2 over 2. What's that equal to? 1. Okay, so this is the chart that you need for problem number 1 right there. All right. Now, as with supplements, I'm not going to put any questions like this on the test. Okay, this is just kind of additional stuff that they want us to do, so you don't have to worry about that. Okay, on the next page is problem number 2. And it says, find the lengths of the sides of the triangle X and Y accurate to 3 decimal places. Okay, good. We get to find some decimals now. I just want to put my right angle there. Going to put y here. Going to put x here. Let's see, we got 25 degrees up here, and we have 13 right there, or 15. There we go. Okay, so let's pick a side, x or y. Which one you want to find first? X it is. So here's the angle that I have. This is the side I'm trying to find, and this is the side that I know. Okay, so which side, what is this side right here called in this triangle? That's hypotenuse, right? Good, 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 good. Okay, so I'm just going to kind of put that right there. In relationship to this 25-degree angle, what side is that one? Opposite. So which one of our trigonometric ratios has opposite and hypotenuse in it? Sine does, right? So that's the one we're going to use. So once you've figured that out, you're in great shape because then it's pretty easy. So sine of 25, that's the angle, that's what I'm always going to put in there, is equal to the opposite side, x, over the hypotenuse side, 15. Good job. So there it is. So that's how you would find a triangle side in this situation. So then we got to find the sine of 25. So we take our calculator, figure out the sine of 25. What are we getting? 0.422. Okay, it says to go 3 decimal places, so that was a good choice of doing that. We put it over 1, make a proportion out of it. And now we cross multiply. So we get x equals 0.422 times 15. 6.33. All right. Good enough. There's our x. All right, so now we got to find y, and there's actually a couple different ways of doing it. We know this one is now 6.33, so we can actually use that. Okay, so let's see, what side is this one in relationship to our angle? Adjacent, good. Now we can use the hypotenuse or we can use the opposite side because we know both of them, so it doesn't make any difference which one we use. All right, let's stick with the hypotenuse because that's the one that we had before. So which one is adjacent and hypotenuse? Which one is that? Cosine, yep. So we're going to go cosine 25 equals the adjacent side, which I don't know, they're calling that y, over the hypotenuse, which is 15. So we'll do that. So I need the cosine of 25. 0.906 equals y over 15. Throw it over 1 because all numbers can be written over 1, and then we'll cross multiply. So y is equal to whatever 15 times 0.906 is. 14.59. 13. 13. Okay. All right, so there's x and y in that problem. Okay. Is anybody not getting these values for their sines and cosines when they're trying them? Okay, it's just probably in a different mode. Okay, so is that an 89, Karina?
Yeah.
All right. Do you see where the mode button is on that?
Mm-hmm.
Okay, push that.
I did.
Okay. Is there something that says angle? No? All right. Hey, let's do the last one here, number 2 or 3. Number 3. Airplane. Oh, good. We actually get a little application here. An airplane's flying at an altitude of 30,000 feet. When the airplane is at a 10-degree angle elevation from the airport, it starts to receive radar signals. How far away measured along the ground? As X is the plane from the airport when it receives the signals, and how far away measured by the line of sight? Y is it from the plane airport when it receives it? Answer both questions. Okay, here we go. So we have a plane here. There we go. Good drawing. Okay, and it is 30,000 feet high, and the angle is 10, and they want us to find X and Y like that. Okay, so here's the let's find X first just for the heck of it. Okay, here's my angle right here, that's 10. So what side is this one in relationship to the 10? Is it opposite, adjacent, hypotenuse? Which one is X? Adjacent, yep, it's right next to the 10. Okay, adjacent means next to. What about the 30,000? What's that one? That's opposite. Okay, so there's my two sides. All right, which trigonometric ratio should I use when I have adjacent and opposite? Tangent. So that's where we're going to go. So we'll go tangent 10 equals opposite side 30,000, adjacent side X. So I need the tangent at 10.976. Okay, that makes sense. Cross multiply. And then what do we do to figure out what X is? Yep, we're going to divide it. Okay, 30,000 divided by 0.176. $174.54. It's going to be a big number. Yeah, it's going to be a big number. Okay, so there's that. All right, now we got to find Y, that line of sight. So, what side is this in relationship to our 10-degree angle? That's the hypotenuse. Okay, so we got the hypotenuse. Let's use the 30,000. That's our opposite. So which one are we going to use for that? Yep, sine. So we go sine 10 equals opposite side, which was 30,000. Hypotenuse, which is Y. And yeah, what I do?
It is 170.454.
It's 170.5.
Yeah.
So right there.
Actually, 170.454. So you're gonna move the.
No.
That doesn't. That would be too small.
Yeah, what I got was 174.54.5455.
Oh yeah, here we go. Yeah, exactly. Yeah, you're right.
0.55. Just call it 6. Call it good. Okay. Okay, sine of 10. What are we getting there?
0.173.
Throw it over 1. Cross multiply. And divide. And what do we get?
173,410.4.
Yep, that makes sense. That's the end of those.
You can send to you?
Yeah. Yeah, you get free points for those. Okay, so I think I'll spend like about 20, 25 minutes or so going over a couple things I want to make sure. Just kind of tie up some loose ends. All right, and then after that, we can carry it how we can do whatever you guys want to do. All right. The things that are causes problems on this particular test is the solving equations part of it. Okay. And most of us are doing a really good job of that. There are a couple of times when there's a couple of problems like this, and I'm just going to kind of make some specific things up here. Some that have a problem like this. There might be one like I'm going to change it a little bit. Let's just do one at a time. Okay. So there might be something like this one here. All right. And what we're going to do is solve this equation. Okay. So what would we do first? There's a couple things you can do first. What do you want to do first?
I would start with the 3.
Yeah, -3 times x plus -2.
So that'd be 5. What would we write then?
-3x
Uh-huh.
plus 6.
Plus 6.
Plus 6. Okay. Good. All right. So, of course, you know the ones that are here are the ones that are doing real well, right? Okay. And they understand that, hey, I got to take that -3 times that 2 and get that -6. All right. So that's one of the things that sometimes can cause problems. People forget, put a minus there, and then I got to dock a point. So I saw that in a couple of the quizzes. All right, and it's a very common mistake. So let's finish this off. So what would we do to finish it?
You could do -5 to 10.
Okay, you could do that. Certainly, that's a fine idea. And this is going to be 5. Then what?
-6.
Yeah, subtract the 6. -3x equals -1.
Didn't you just add the 5 and the 6 together?
Yes. So, you could. You know, back here in the beginning, we could have subtracted 5 from both sides too. So there's different ways to approach it, right? You know, as long as you understand and get the right answer, it just depends on how you want to get there. All right, there are many roads. All right, let's take a look at one like this. This is another very common error. Okay? So we have a problem like this one right here. What would we do here?
Take the negative times 2x.
So what's that going to give us?
3 negative 2x minus 1.
Okay, common error. A lot of times some people will take this 3 and distribute that through because they're just not reading it. It's not 3 times that, it's 3 minus. So you want to make sure that you bring the negative through. Okay, the 3 just stays there. All right, so be careful with that. Okay, let's finish this one. What do we want to do first?
You can add 2 to the 4.
Okay. So that gives me 3 minus 1. Let's just figure that out. 2 equals 6x minus 8. And then add 8 to the 2. And then we divide. It's 5/3, so 1.6 repeating. Okay. All right. So there's a common mistake. All right, that right there. All right, so we went over a couple different ones that I've seen. Okay, another one. Okay, so let's do one like this. What are we going to do first on this particular problem? Distribute. So what do we get? Okay. So what should we do now?
So with the combining the 12x and the 2x, that would be 10x.
And now?
Add the 2 to the 5.
Now?
Subtract the 10x.
What is this going to give us? 0. Okay. What does this mean?
Yeah.
Close. No solution. No solution because 7 doesn't equal 0. Okay. All right. You know, I saw a couple, again, some people say, hey, this is 0x, and then stop because they got confused. But 0x is just 0 because there's just nothing there. And whenever you see this and this on the same side, right now we could have concluded something. Okay? We know those are going to cancel. We could have just wiped them out right there and said, hey, 5 doesn't equal negative 2. We didn't have to actually do those next steps. All right? Three, 2 minus 4 plus 1 equals 8x minus 2x. Okay, let's try this one out. What should we do first? distribute that. So we're going to get 6x minus 12 plus 1 equals 8x. What are we going to get here? Minus 2x minus 10 minus 1. This is a plus 1. Looks kind of messy, but it's a plus 1. Okay, then what? Okay, what's that going to give us? Okay, and right here? What's that going to give us? Okay, uh-oh, same thing on both sides. What's our conclusion to that? Not no solution.
Undefined.
Not undefined. Oh my goodness. They're the same thing, right? All real numbers. Okay? No matter what number you put in there, it's going to work. So on solving equations, one solution, no solutions, all solutions. Those are your possible situations. Okay? And make sure that you conclude. Don't stop here. Make sure you tell me what the answer is. Okay? I got to have that. The only other one I've seen is when it gets down to a situation like this. Although not so much with, you guys have done pretty well with this part. When you divide by 3, what's the answer to that going to be? 0, yeah. All right, I've seen that one, but you're pretty good about that one, so I don't know if that's going to be a main problem. Okay. The only other things that I saw were on the last quiz we took. Some of you going, yeah, okay. And I don't, I'm speaking, I don't know who did what or anything, but I know that, what does product mean? Yeah, some people put add, okay. Make sure you solve it when it says solve it. Let's see, that interest one, that was fine. There wasn't too many problems with that. A little bit on the perimeter one. Make sure you draw a triangle and you put some stuff down on there, because then I'm going to give you the benefit. I'm going to give you some points for that. If you don't really have a triangle drawn, or excuse me, a rectangle drawn or anything, then it's hard for me to give you anything. So make sure you do that. Okay. Let's see. So if there's something where it says the length is 3 times the width, okay, plus 5, and the perimeter is 102. Okay, so in that case, the length is what you know is 3 times the width, so we'll let the width be x, and we'll let the length be 3x. Oops, plus 5. Okay, so that's kind of what that's going to look like. Okay, you don't know what the width is, so you make that x, but you do know that the length is 3 times the width plus 5. So that would go there. And then when you add it up, and there was a number of people that kind of got to this point. Okay, and then we added it all up. That's where the problem kind of came in. So if we add these up, we'd have 3x plus 5, and another 3x plus 5, and an x, and an x, and that's equal to 102. Then you would just solve out that equation. Okay, so basically you're just walking around the rectangle like this. 3, 6, 7, 8 plus 10 equals 102. And then from there you just solve it out. Okay. And if I make it up, it very well could have a decimal answer, so don't get too distracted by that, as of this one does. Okay. The formulas will be on the test somewhere, so you're not going to have to memorize any of the formulas. Okay, they're going to be there. Make sure you're using them right. I know there was the one that was the cylinder like this and had a little cone thing on top. Okay, and this was like, I don't want to do the exact one here. If make this 20, make this 10, make that number 10. Okay. So for the cylinder, the volume is equal to pi times r squared h. R is a radius, but in this case it's going to be half of that. And the height is also 10. Okay? So you would figure that out. Then for the volume of the cone thing on the top, it's the same formula, except you got to divide it by 3. Okay? But the radius is still 10 and the height is still 10 in that case. Okay, so they're the same formulas. All right. On the sphere, the hemisphere one, it looks like a bowl. Formula was done correctly. It was just forgotten to be divided by 2 because it's only a hemisphere. There was the C1, where a lot of people put 7 by 6 on the top, but it's actually 7 by 7 because there's a 5 drawn in there. Okay, so those were the little mistakes that I kind of saw on these ones. Again, the formulas will be there on the test, so you don't have to memorize that. And those are the only ones I saw. Does anybody have anything that you want to go over with me? Or you can do that privately if you want to after we're done here. But those are the only things I have. I think the review is... Did anybody... Some of you have it, right? Okay. You know, that's just a study guide for you. You don't have to turn it in. Yeah.
That's about exercise 54, which is find the area of shaded region.
Which page is this on?
179.
179?
This section 2.6.
Which one, buddy? 67?
54.
54? The shaded region?
Uh-huh.
Okay.
So we will find the area of 2 circles, but what are we going to do then?
Like that, right? Okay. All right. So what we want to do is find the area of the big square, or excuse me, big circle first. Okay. So if this is 2 here, this is 2, this is 2, this is 2. It's not going to be 8 because the radius is going to be that 4. All right. Then what you want to do is find the area of one of the smaller circles. What's the radius of the smaller circle? 2. Right. But you have 2 of them, correct? So we're going to subtract that off. Yeah, whatever 8 pi is. Okay.
So we can leave it at 8 pi, or we can make the nearest number.
You can leave it. You can leave it as 8 pi, or you can figure it out. Okay. Well, I'll hang out as long as you, the last person. So if you want to take off, if you have any questions, shoot me some emails if you have something you want to talk about, or I'll be happy to stick around. Yes, ma'am. I'm going to shut this down first, okay?
I have a major problem.